So what we're talking about today is the introduction to kind of conic sections, but mainly parabolas. There's many different types of conic sections that we can have. Conics. So we could have circles, ellipses, parabolas, and hyperbolas. A conic section, or simply conics, is the intersection of a plane and a double-naped cone. So essentially two cones put together at the tips. Notice in figure 10.7, in the formation of the four basic conics, the intersection planes do not pass through the vertex of the two cones. So wherever the two cones intersect, they do not intersect. They're not looking at that plane. Essentially, the only one that would really work for that would most likely be the hyperbolas, but those two functions would be touching each other, and it does not work. Now, for these here, well, okay, I take that back. So we could have a point for a flat plane that goes where the intersection is. A line, or essentially goes along that there, y equals mx plus b, or two intersecting lines, two lines that cross. So this here, we would have two lines that cross, but it would not be considered a hyperbola. Because a hyperbola is going to be a U-shaped, two U-shaped graphs going in opposite directions. This here would just be an equation of two lines, or we can consider possibly absolute value functions, V-shape, in either way. Now, there are several ways to approach the study of conics. You could begin by defining conics in terms of the intersection of planes and cones, as the Greeks did, or you can define them algebraically in the general second-degree equation, this here. However, we will study a third approach in which each of the conic sections is defined as a locus collection of points satisfying geometric properties. For example, we can satisfy it with a circle, because this equation here satisfies all points on a circle. X minus h squared plus y minus k squared is equal to r squared, just the equation of a circle. And if we know the center of the circle and its radius or point, then we can find the equation that defines it. Now, for us today, we're mainly going to focus on parabolas. Now, the basic equation for a parabola is ax squared plus bx plus c. It's a parabola that opens upwards or downwards depending on the value of a. Because if a is negative, it opens down. If a is positive, it opens up. Now, the following definition of parabolas is more general in the sense that it's independent of the orientation of the parabola. A parabola is a set of all points, x, y, in a plane that are equidistant from a fixed line, called the directrix, and a fixed point, called the focus, not on the line. The vertex is the midpoint between the focus and the directrix. The axis of the parabola is the line passing through the focus and the vertex. So we kind of have this general information. Now, if we use the focus, vertex, and directrix, we get these two main equations. And the first one we get is x minus h squared is equal to 4p times y minus k, where p is different from 0. And this here, the vertex, vertical axis, the vertical axis and the directrix, y is equal to k minus p. So we have this here. Now we also have y minus k squared is equal to 4p times x minus h squared. No, x minus h. No square. No square here. And our directrix for this here is x equals k minus p. The focus lies on the axis p units directed distance from the vertex. If the vertex is at the origin, then the equations take on this form here. Essentially, for the bottom two, x equals 4py and y squared equals 4px, it's really going over the fact that h and k are both 0. H and k are both 0. And the focus Focus lies on the axis p units directed distance from the vertex. So the vertex for either one of these here is going to be h comma k. And it kind of mentions this here. The focus lies on the axis p units direct distance from the vertex. So this is a vertical axis. So that means that this one here, since we're x squared, is going up and down. So the vertex, or the focus, is going to be p units from the here. So we're dealing along the y. So this here would be h comma k plus p, and this here would be h plus p comma k. Because when x squared, we're dealing with a parabola that's going up or down, so the focus is going to be up or down vertically. Or when we have y squared, we're dealing with a parabola that's going to the left or to the right, so its focus would be moving along the x-axis. Questions on any of this here? Y'all remember doing this? Well, we dealt with it more in the form of y is equal to 1 over 4p x squared, or x is equal to 1 over 4p y squared in the general sense, when the vertex was at 0, 0. When the vertex was not at 0, 0, we dealt with it in the form of y is equal to 1/4 p times x minus h squared plus k, or x is equal to 1 over 4p times y minus k squared plus h. I have a feeling these formulas look a little bit more familiar. A little bit, but not too much. But they're the same thing as what we've been given. They're just not written as x equals or y equals. So we look at this here. X minus h squared is equal to 4p times y minus k, our top equation. Our focus is h comma k plus p. And when we have y minus k squared, our focus is h plus p comma k. So as we have here. Any questions on this here? So we have these main equations. So the first thing we're going to do is we want to find the standard form of the equation of the parabola with the vertex at the origin and a focus at 0 or 2, 0. So if the vertex is at the origin, its point is 0, 0. So our focus is 2, 0. Parabola with the vertex there and a focus at 2, 0. So when I change from the focus to vertex, I'm either moving it up or down or left and right. Yes? So which direction did it move? So it moved to the left, to the right. It's moving in the x, because the x values change from the vertex to the focus. Yes? So when we look at our equations, because one of them has a vertex of hk and a focus of h comma k plus p. The other one has a vertex of hk and has a focus of h plus p comma k. So which one do we want to use? The one that has a change in the x-axis, where the vertex, or the focus, is h plus p comma k. Because when we look at this here, so in either one, well, between the vertex and focus, well, if the h changes, the first value changes, we're dealing with our y minus k squared. We're dealing with the y minus k squared is equal to 4p times x minus h. We're dealing with this equation because of the fact that the focus changed in the x location. Because what we're saying is that the focus for this here is h plus p comma k. And I know that since vertex is h comma k, well, the k value did not change. It is still 0. So if I were to fill this in, well, I know k is 0. Well, here, so k is 0. Well, h is also 0 because the vertex is 0, 0. But the focus is 2, 0. So I know that there's a change in the x location, which means p in our case must be, because h plus p is equal to 2. I'll write it out. And what we're saying that the focus, h plus p, is 2. Well, I know h is, so 0 plus p is 2. Well, p is equal to 2. And the reason we need that is to actually finish out this equation. The value of k is 0 from our vertex is equal to 4p is x minus well, here I have y minus 0 squared, which would just be y. 4 times 2 is x minus 0 is times 8 is. So we get this equation here. Now, most likely, we're wanting to get the variable that's not squared by itself. So I would divide both sides by, which would tell me x is equal to, well, we can put the 1/8 out front. Y squared. We kind of like having that number out in front of the variable instead of the variable in the numerator. So we get this here. That's how I would normally write it, but they're going to take x squared equals 8x. Or y squared equals 8x. Now we can use the graphing utility to confirm this equation. To do this, we let y1 equal the square root of 8x. We square root both sides. To graph the upper portion, then we let y2 be equal to negative square root of 8x to show the lower portion. And I'll pull that up here in a second and we can look at that. Equals clear. So because this deals in y equals and not x equals, we have to kind of break it up. Square root of 8x negative square root of 8x. Go to and make a little bit of a difference. Second square root 8x delete x. Hold on. There's a graph. There it is. So we get the top and bottom half of the parabola. And that'd be our answer. Questions on this here? Okay. Now we're going to do some more of these here because that's the only one these slides gave us. Find the standard form of the equation of the parabola given that the vertex is 2, 1 and the focus is 2, 4. So we can start off by figuring out which one of the equations we will be using. Are we going to have x minus h squared or y minus k squared?
Because the second one changes.
So the second one changes, our y value changes from the vertex to the focus. And that is true for when y is, or y minus k squared, yes?
I'm at
X. So the main focus point that equation we're going to be using, x minus h squared is equal to 4p times y minus k. Now what we do know for sure is that h is 2, because h is with x, so we want the x value which goes first. So you have my minus y goes with its y value on the vertex. Now the only value we do not have is p. Now we do know that k plus p is equal to, well, k in our case is, because 1 plus 3 is 4. So this right here is 3. Four times 3 is? Yep, and that's where we can leave it, surprisingly enough. We're not actually having to solve for y, getting y by itself. But even if we wanted to, what we could do is we can multiply both of these by 12. Then I can add 12. And then divide everything by 12. And I get 1/12 plus 1. Would be the exact same equation if we wanted to solve it. Or essentially, we could have divided both sides by 12 and then added 1 to it. Any questions on this here? Okay. Okay. I am. Because the directrix kind of gives it away. When the directrix is y equals, we're using our x minus h squared is equal to 4p times y minus k. And it tells us the directrix is equal to y is equal to k minus p. Well, I know from the starting equation that k is 0 because the vertex is at 0. Well, p is not -4, but the directrix is -4. What the directrix is equal to is y equals -4, so I'm plugging -4 in for y. We're actually wanting to know the value of. So now we can plug this information back in. Well, here we would have x minus 0 squared is equal to 4 times 4 times y minus. For here I'm just going to have x squared is equal to 4 times 4 is. That's it. Well, that's it, because this here and the assignment, neither one of them is going to make us do anything beyond this here. They're not going to make us actually solve for y or x by itself. Any questions on this here? We good with this here? inside there, go away. Now let's do this. Actually. It would be the second one because the direct 6 gives it away, x equals. So that means we're going to be using y minus k squared is equal to 4p times x minus h. I'm going to go ahead and plug in what I already know. So y minus, do we know the value of k?
Yes, it's 2.
It would be 2. I don't know the value of p. Do I know the value of h?
No.
No. Because the focus is, for our second one, h plus p, comma, k. So the focus is telling me that h plus p, whatever it is equal to 2. Now the direct 6 is telling me that negative 2 is equal to k minus p. Well, we can use those two equations together because I know that k minus p is equal to negative 2. I know that, not k. This should not be h, this should be k. Make sure I have everything written down correctly. Focus and directrix, yes. And it would be the y squared. No, I had that right. I don't know why I was second guessing myself because it is h plus p is equal to 2. And here we have k minus p is equal to negative 2, yes? I was thinking this was a little more complicated than what it was.
That's 2.
That's 2. And we can h is equal to 4. H plus 4 is equal to 2. So h is 4 times 4 is 2. And we get x plus 2 because the negative and negative make a positive. I just want to make sure I wrote those equations down correctly. Yeah, I knew it. No, I knew I was doing the right step. Because it wasn't, I hate it when I write these things down wrong, because then I mess all this up. But it's 4 times p times x minus h. This here is h plus p is equal to 2. Here, negative 2 is equal to h minus p. Yeah, for some reason I wrote k twice on the board. I'm glad I looked back at that. Because what I was wanting to do was correct, because it would be h minus p is equal to negative 2. H plus p is equal to 2. We can solve this by a system of equation using elimination. Because h plus h is negative p plus p, well that is negative 2 plus 2 is, so h is equal to because here we would have 0 plus p is equal to 2. P has to be 2. Well, 4 times 2 is 8, and then we have x by itself. Questions on this here? Equals. So this would be the first one, and I'm just making this one up on the spot. So we would have x minus h squared is equal to 4p times y minus k. Because we know h is p, h is 3, not p, because the focus is going to be h comma k plus p. The directrix, so our negative force, so our k minus p is equal to, and our k plus p is equal to, and just like the one before, we can use systems of equations. So k plus k gives us, the p's will cancel, equals negative, divide both sides by 2, and we get k is equal to, so negative 6. So up here we have negative 6 plus p equals negative 8. So we'd have x minus 3 squared equals negative 8 times y plus 6. And we'd leave it at this here. We don't have to multiply through by the negative 8 and try to get y by itself. Any questions on this here? Any questions on any of this here so far? We're good with this here? I think we feel good, especially if we're given the vertex and the focus or vertex and the directrix, the h comma k, and x equals or y equals k minus p or h minus p respectively. Yes? For the most part. And then I think you all feel comfortable giving the focus and the directrix. That takes care of that. Okay. Yes.